Hey guys, Chapter 6, Section 1 video here for you. Today we are going to work on what generalizations can I make about exponents. Generalizations mean we're going to start looking for some patterns and trying to kind of develop some rules that we can use every time with exponents. So we're going to dive right into that today and we're going to try some problems. Example 1, here's what we're going to do first. 3x squared times 6x to the third power. Now we should be able to do this now. We know the strategy is to expand it out, break it out into its little parts, and put it back together. So let's expand. That would be 3x times x, and that would be 6x times x times x. Let's rearrange that. That's 3 times 6, which is 18. And then how many x's do we have? Oh yeah, we have x to the 5th power. So our simplified solution is 18x to the 5th power, and there's our answer. Let's look at another one here. How about this? Negative 2ab to the third over 10a squared b. So we've got a fraction, but we're still going to expand, except with fractions we look for the power of 1. So we're going to break out the top. So we're going to have still a negative out in front of the fraction. I'm not even going to think about the negative sign. On top we're going to have 2ab times b times b. And on bottom, how about we change 10 to like 5 times 2, or 2 times 5. And then we'll have a times b. Now where are my power of 1s? Well, I see the 2's for sure. I see the a's. I see a pair of b's. Do you see anything else that could be a power of 1? I don't think so. So on top we still have b times b, and on bottom we still have a 5a. So that's going to be b squared over 5a, but with a negative sign out in front. Those negatives just stay in front of the fraction through the whole process. And we've got our solution, negative b squared over 5a. So we just leave it with that negative. All right, you try. Why don't you try a couple problems here? Here are your 2 questions. We've practiced this in a few videos now, so I'm hoping you're really getting the hang of it. Hit the pause button on your device and go ahead and simplify yourself. All right, let's check your answer. You have both problems done. You've simplified and you're ready to see if you did it correctly. So let's start with A first. If we break it out, it's 5m times m and 5m times n. Well, I see power of 1s kind of everywhere actually, which means nothing's really remaining other than the power of 1. So what's our answer? Well, our answer is 1. That's our solution. That's our simplified answer. All right, let's look at B. Let's break this one out. Let's see, it'd be negative 3x times y, and then it'd be 3 times x times y. So we rearrange the numbers. Negative 3 times 3 is negative 9. I see 2 x's, so x squared, and I see y, and y, so y to the 3rd power. So our simplified answer is negative 9x squared y to the 3rd power. How'd you do on this? Are you getting better at expanding and simplifying? Because if you're getting them right, that's a really good sign. All right, we're going to do example 3 now. And here is example 3. We're going to start making them harder. 2x to the 57th power times 4x to the 31st power. Now, what's our strategy? Well, it's always expand and simplify. But do you really want to expand x to the 57th power? Think about that. That's 57 x's. That's kind of crazy. I mean, you could, if you really wanted to, write all that out, but it sounds wild to me. So instead of expanding, go back to example 1, the very first problem that we did in our notes today. Can we find a shortcut? Can we make a generalization? So let's look at this problem back on example 1 when the powers were smaller. Remember what we had? 3x squared times 6x to the 3rd. What do you notice about the powers? The answer is x to the 5th, but what do you notice? Do you notice that 2 plus 3 is 5? That if you add the powers, you get your solution? I know this is a multiplication problem, but 2 plus 3 gives you x to the 5th power. So we have a little bit of a rule here. Adding the powers is how you can simplify this problem. So like the 57 and the 31, although I could write them all out, what I'm really going to do is just add them together. So I've got the 2 times 4, I got to do that, and then I'm going to have x to the 57 plus 31. Now 2 times 4 is 8. 57 plus 31 is going to be 88. So our answer is 8x to the 88th power. And we got that answer without expanding because we generalized a rule that we could just add the powers. Let's look at this one. How about this? If we use that rule, add the powers, how would that work on this? 5x to the 4th y squared times 3x y to the 6th. Now we could break this out, expand it, and put it back together totally. But right now, I want to do it a little differently. I'm going to put the numbers together, 5 and 3. Then I'm going to put the x's together as x to the 4th power plus 1 more. And then I'll put the y's together as y to the 2nd power plus the other 6. We're going to add the powers. So we have 5 times 3 is 15. We have x to the 5th, y to the 8th. There is our simplified answer. I could still go expand this and get the same answer. Maybe that's my level 4 work, expanding and using a shortcut. But they should both end up with the same solution. How about this? 2x to the 100th over 8x to the 20th. Do you want to expand this one? X times x times x times x times x times x 100 times? That sounds like a lot again. Expanding does not sound like a great plan. So let's think about this problem for a minute. Let's think about a simpler problem actually. What if in our little thought cloud we had x to the 3rd over x to the 2nd? I would expand this problem. It wouldn't bother me to expand this. That'd be x times x over x times x. Now we look for the power of 1s and we get rid of the power of 1s. And what's our simplified answer? Yeah, we're left with just an x over 1, which is x. But why am I showing this to you? Well, when we're left with the answer x, it's kind of like x to the 1st power. Look at the powers. What's the relationship between these powers? Well, 3 and 2, if you do 3, take away 2, you get 1. So it looks like we can subtract the powers. 3 take away 2 is 1. Now, if that's a rule that I can generalize, let's go back to this one. Looks like instead of expanding, we could subtract the powers. We could do 100 take away 20. That would make this problem so much easier. Now, the 2 and the 8 is a different story. We're kind of stuck with that. But we have 2x to the 100th minus 20 over 8. In fact, I'm going to break that into 2 times 4 is 8. So I can get rid of the power of 2's, or power of 1, power of 2's, power of 1. But I have 100 minus 20 is x to the 80th power. So I get x to the 80th power over 4 as my simplified answer, which was way easier than expanding all those x's out. And there's our solution. All right, let's try another one. Example 6. So how about this one? 12x to the 3rd, y to the 5th, over 14x squared, y squared. We totally could expand it and do the power of 1s. But instead, I'm going to do this. I'm going to break out the numbers. 12 is going to be 2 times 6. 14 is going to be 2 times 7. But then for the x's and the y's, I'm going to subtract the powers. I'm going to do x to the 3 take away 2. I'm going to do y to the 5 take away 2. I'm going to get rid of the power of 1 with the numbers, 2's. The 2's are going to go. Here's my answer. I have 6. I have x to the 3 take away 2, that's x to the 1st. And I have y to the 3rd all over 7. And I really don't need that first power, so I'll just write 6x y to the 3rd over 7. That's our simplified solution. And it's the same as if I had decided to expand it out. Think about expanding. I'm just going to show the expansion. If I had written all the little parts out and got rid of all the power of 1s, I still would have had the same answer. It just would have taken a little more space to write it all out. But it still would have given me the same thing. All right, and really doing both of those is my level 4. It's kind of advanced work. I'm showing 2 ways of thinking about this problem. There's definitely going to be some more videos on this, but I hope at the end of this video you're kind of taking away that when you're multiplying variables, you add the exponents. Now people get that confused all the time because they're like, wait, it's a multiplication problem. Why am I not multiplying the exponents? But it doesn't work. You got to add them. And if you're dividing the variables like in a fraction, the rule is to subtract the exponents. Subtract them away from each other. Okay, we'll definitely practice a lot more of this, like I said, and I'll see you guys in class. Thanks for watching. Bye.